Welcome back to another one of my integration examples videos, where this is the sixth one. Each video has got progressively harder, or I've added different techniques in that I hope that you haven't known for the sake of you getting something out of it. But if you know some of the techniques, good. It's good, all more power to you. But I'm basically make each example different from the other in some way, and slightly harder than the previous examples. But anyway, usually I do 3 examples, but because these 2 are integration by parts, I will only do 2 because integration by parts takes forever. So let's start with example 1, which is f(x) equals x multiplied by sine x. Simple, nice and easy. So we find the integral of both sides. And now, the by parts formula, I'm going to do like a mixture of Lagrange and Leibniz, but it's basically f multiplied by g dash dx equals f multiplied by g minus the integral of f dash multiplied by g dx. Okay, so essentially we want this to look like that, and saying we want one to be f and one to be g dash, because we need an f value, we need an f dash value, and we need a g value, and we need a g dash value. So all we've got here, we've got to pick one to be f and one to be g dash, and then work out the rest of the values just with those two. Okay, so first, well, we better say by parts, because you should always write what method you're using. But f generally is the one that simplifies the easiest when derived, so it makes the process simple when you get to this area. And g dash is just whatever. But when you're using things like natural logs and exponentials, you tend to want to make the f be that exponential or log, because when you find the integral of it, it gets painful. So, but in this case, we just have an x and a sine x. So we're going to call f x, and we're going to call sine x g dash. Okay, so we find the derivative of x, which is 1. That's why we like that, because it's 1's easy to work with. And g, well, g dash is sine x, therefore g must be negative cos x. I'm finding the integral of it in a way. I'm not putting plus c because this is sort of like, we know what g is, that we know in this stage that there can't possibly be a constant there, because it's just, well, they probably could, but we assume there isn't a constant in there. That's the way I was taught, to not assume that there's a constant there. I'll put a constant in later when we get to this bit of working, but not here. Anyway, right onto it. So that's the formula, and this is what we will have to work with. So I'll rewrite the question, which is the integral of x sine x dx, and that will equal f is x, g is negative cos x, minus the integral of f dash of x, which is 1, so you won't worry about it, and g, which is negative cos x dx. Okay, basically we're just going to make this negative x cos x, just expand it out, and over here there's a negative. Essentially we can think of it as being negative 1 multiplied by cos x. Negative 1 is a constant, we bring the constant out. Negative 1 multiplied by a negative is a positive 1. And we don't write the 1 there because we're going to be multiplying it in later, and multiplying anything by 1 is pointless to write. So we just have the integral of cos now. So negative x cos x, no problem there, plus, well, the integral of cos x is sine x. Just like the derivative of sine x is cos x, the integral of cos x is sine x plus c. So I like to put the constant in here at this stage. But you can put it in at the beginning, you just have to carry it through with you. Anyway, so we don't really need the brackets at this anymore. So I'm going to rewrite this so it's going to look like sine x minus x cos x plus c. And that is the answer to the integral of x multiplied by sine x. See, not so bad. Now for another example. Example 2. So fx will equal x to the power of 4 multiplied by ln of x. Find the integral of both sides. Okay, and the formula before, quickly rewrite it. It was f g dash dx equals f multiplied by g minus the integral of f dash g dx. Okay, so what we've got to pick one of these to be f and one of these to be g dash. And like I said before, the natural log, we don't want that to be g dash because we'll have to integrate it to find g. And integrating ln of x is a pain because it'll just make things harder and longer. So we're going to make this the f and we're going to make this the g dash. So we have f dash, g dash. We said f was ln of x. The derivative is just going to be 1 on x. We said the g dash was going to be x to the power of 4. The integral, you add 1 to the power and you divide by the new power. And just like before, I'm not going to add the constant here. You can if you want to, but I don't do it here. Okay? So we have integral of x to the power of 4 multiplied by ln of x dx equals f we said was ln of x, g we said was x to the power of 5 on 5, we multiply that together, minus the integral of f dash, which we said was 1 on x, multiplied by g, which we said was x to the power of 5 on 5 dx. Okie. So we can cancel out this x and we can cancel out one of them up here. So this will now be a 4. And this 1 over 5 will bring out the front because it's a constant. So I'm just going to use quotation marks to signify that above instead of rewriting it. Subtract the 1 over 5 integrand of x to the power of 4 dx. Okay, so just like before, quotations, minus 1 over 5, bracket, just like before, x to the power of 4, the integral, add 1 to the power, divide by new power, plus c. Now I add the plus c in. Okay, so quotations again, subtract 1 over 5 multiplied by x to the power of 5 on 5 is going to be x to the power of 5 on 25 plus c on 5. Okay, I'm going to write over here that h equals c on 5, so I can just write h whenever a c on 5 comes up. And now, it says ln x multiplied by x to the power of 5 on 5, because this is the same as this, because I'm multiplying the ln of x on top of the fraction. Minus x to the power of 5 on 25 plus h. Now to give these the same denominator, what I'm going to do is multiply the top by 5. The top and bottom of this by 5, which will give me 5 ln of x multiplied by x to the power of 5 on 25 minus x to the power of 5 on 25 plus h. So essentially we could just join this together, put the minus sign up here, and just put a 25 in the middle. Now that it's together, if you notice there's an x to the power of 5 multiplied to this side, and an x to the power of 5 multiplied to this side. Well, it's multiplied to the negative 1 that's there. So we can factor that out, and we can have x to the power of 5, bracket 5, ln of x, minus 1 over 25 plus h. And that is the answer to the integral of x to the power of 4 ln of x. Okay, well thanks for watching this video. I hope you learnt something, and I hope you have a good day.